Assalamualaikum and hi everyone. Today, me and my group mates will talk about logical connective. My name is Muhammad Humam bin Adnan. My ID number is 2020475932. Alright, next we will move to the content of this topic. So, logical connective, we have statement and primitive statement. What is statement and primitive statement? So, a statement is a declarative sentence that is either true or false, but not both. As you can look here, example, today is raining. This statement or this sentence can be true and can be false, but not at the same time. So the primitive statement consists of only a statement in which it has one subject and one predicate. Connective can use to combine two or more primitive statements, or we call it as compound statement. There are 5 types of logical connective, which are negation, or we call it as not, conjunction, or we call it as and, disjunction, or we call it as or, implication, if then, and the last one like conditional, if and only if. So what are these type of logical connective? We will look after this. Alright, next we will move to the truth value and truth table. You can look the logical connective table here. We have 5 types. The first one is not. That is a symbol for not. The compound statement is not P or not Q. So in the symbolic form you can look here, not P or not Q. The second one we have N. That is the symbol for N. The compound statement for N is P and Q. In the symbolic form we have P and Q. The third one we have OR. That is the symbol for OR. In the compound statement is P or Q, and that is the symbolic form for P or Q. The fourth one we have if then. That is symbol for if then. So the compound statement, if P then Q. In the symbolic form, we take a look at here, P if then Q. If P then Q. Alright. And the last one we have by conditional, if and only if. The compound statement, P if and only if Q. In the symbolic form here, P if and only if Q. Next, we move to the first type of logical connective, which is negation or not. If P is true, not P is false, and if P is false and not P is true. You can look the truth table here. If P is true, then not P is false. And if P is false, not P is true. We can conclude that not P has opposite truth value from P. The second one is conjunction, or we call it as AND. If P is true and Q is true, then P and Q is true. Otherwise, P and Q is false. As you can look at the truth table here, there is only one condition and one situation that make the statement P and Q is true, which is if P is true and Q is true. Right? As you can look there, I put multiplication, assuming that true equals to 1 and false equals to 0. Right? So if you multiply 1 with 1, you get 1, which is true. And if you multiply 1 with 0 or any number with 0, you will still get 0 or false. The third one is disjunction, or we call it as OR. If P is true or Q is true, or both P and Q is true, then P or Q is true. Otherwise, P or Q is false. You can look at the truth table here. If P is true and Q is true, then P or Q is true. If P is true, Q is false, P or Q is true. If P is false, Q is true, the statement P or Q still be true. But if P is false, Q is false, the statement P or Q will be false. I put the addition. If you add 1 with 0, you get 1. And if you add 1 with 1, this maximum number is 1, which is still true. But if you add 0 with 0, you will get 0, which is false. Fourth one is conditional statement. If P is true and Q is false, then the P implies Q is false. Otherwise, P implies Q is true. There is only one condition or one situation that makes the statement P implies Q is false, which is if P is true, Q is false, or we call it as if your hypothesis is true and your conclusion is false, the statement will be false. Other than that, the statement always be true, as you can look at the truth table here. Last one, we have a conditional statement. If P and Q have the same truth value, then P if and only if Q is true. Otherwise, P if and only if Q is false. As you can look at the truth table here, if P is true, Q is true, the statement will be true. If P is true, Q is false, the statement will be false. If P is false, Q is true, the statement will be false. And if P is false and Q is false, the statement will be true. So we can look here, the same truth value make the statement true.
Now let's start with question number 1. Okay, each of the following statement is false. If Sarah gets high marks in the exam, then Liza does as well. Liza does not get high marks if and only if Aline get high marks. So determine the truth value of the following statements, which is Sarah get high marks and also Aline get high marks. So now it's my turn to tell you how to answer this question. Okay, the statement is, if Sarah gets high marks in the exam, then Liza does as well. And the second statement is, Liza does not get high marks if and only if Aline gets high marks. Okay, from this statement, we could identify that P is Sarah gets high marks in the exam, Q is Liza gets high marks in the exam, and R is Aline gets high marks in the exam. Okay, from that statement also, we could say that P is implies to Q, and also not P if and only if R. Okay. Based on the question, it says that those statements are false. So from that, we could say that P implies to Q is false and not P if and only if R is also false. So from this information, we could say that we could know that P, the truth value of P is true and the truth value of Q is false, and so on and so forth. So from this, we could answer the question. Now let's move to the question 2. The question is, each of the following statement is true, which is Kaula is a clever student and Humam or Izzah likes to play badminton. If Humam likes to play badminton, then Kaula is not a clever student. So from this, we have to determine the truth value of the following statements. So the question is, Izzah likes to play badminton and also Humam likes to play badminton if and only if Kaula is not a clever student. Okay, let me tell you how to answer this question. Kaula is a clever student. Humam or Izzah likes to play badminton. If Humam likes to play badminton, then Kaula is not a clever student. So from those statements, we could say that P is Kaula is a clever student, Q Humam likes to play badminton, and R is Izzah likes to play badminton. So from that statement, we could identify the statement in symbolic, which is the first is P and the second is Q or R, and the third is Q implies to not P. Based on the question, it says that those statements are true. So P, Q or R, and also Q implies not P. It's all of them are true. Okay. So from this, we could know that Q is false, R is true, and not P is false, and Q if and only if not P is true. So now we can answer the question.
Example 3. If P and R implies not Q or S is false, find the true value of not R or P, or Q implies not S if and only if R and P. The solution is P and R implies not Q or S is false. So from that we can figure out that P and R is true while not Q or S is false. From not Q or S, we can know that both not Q and S is false, so we know that Q is true. From P and R, we can know that both P and R is true. After that, we will find the solution for the question, which is not R or P or Q implies not S if and only if R and P. Not R is false, not S is true, not R or P is true. Q implies not S is true. And then we know that not R or P or Q implies not S is true. Then we will find R and P, which is true. And then from that, 1, not R or P or Q implies not S if and only if 2, which is R and P. So the answer is true. So the conclusion is not R or P or Q implies not S if and only if R and P is true. Okay, next example, example 4. If P and Q implies R is false, find the true value of P and not Q or R implies Q or not P. The solution is P and Q or implies R is false. So from that we know that P and Q is true while R is false. From P and Q, we know that both the true values for P and Q is true. After that, we will find the solution for the question, which is P and not Q or R implies Q or not P. So the true values for not Q is false, not Q or R is false, P and not Q or R is false, not P is false, Q or not P is true. So from that we will know that the true values for the question P and not Q or R implies Q or not P is true. So the conclusion is the true values for P and not Q or R implies Q or not P is true.